So, can everybody hear me? Yeah, I can hear myself. So thank you very much, Uwe, for the introduction, and thank you, C-Parity Events, for the speech and for the time slot. And thank you, everybody, for the attendance here. So it's the first time for me being on such a big stage. So let's get through this. And I'm happy to be here, and a little bit about myself. I'm, as Uwe told you, an enterprise account executive at Cybers. I work at Cybers for like a little bit more than 1.5 years. And to my background, I'm an industrial engineer. Started off as a carpenter, but studied for and worked for like 4 years in automotive industry, like automotive suppliers in production planning and purchasing, and ended up in sales. And today I'm going to tell you about how you can achieve real quick, 20 times faster industrial IoT implementations via Industrial DevOps. So what is Industrial DevOps? I'm going to show you that. I also give you a short example about what our customers do. And I'm going to introduce you a little bit into the whole factory data hub and Industrial DevOps topic. So, oh, that's one slide ahead. So 10 years, in the last 10 years, so Industry 4.0 is existing for over 10 years now. And within those 10 years, just under 60%, like 58 or 59%, took way too long to complete, and 52% didn't even get realized or didn't even realize any value. So a bigger problem is even that most of the use cases are stuck in pilot stage. We heard today and before from Aptiv that it's critical to get time to impact with use cases. So use cases need to be realized very quickly to get value, and so that they don't get stuck in that pilot phase and they need to get out of their silos. So if you are taking too long for realizing your use cases, you have the risk of losing competitiveness. Oh, this is the wrong presentation. Yeah, but let's commence like this then. Yeah, I want to show you how to get from years to weeks. So like from years of implementing use cases into implementing use cases within weeks, like for digital innovations in factories. So first, I'm going to show you how to get from years to weeks, like what is it meant, and what Industrial DevOps is, and then I'll give you the automotive example. So what we've seen at our customer side, so like, as you know, I'm 1.5 years into Cybers, or a little bit more, but I had a couple of dozens of talks to various customers, and my colleagues and me, we have all experience together for more than 8 years in industrial IoT deployments. And so what we've seen is that when the production manager, and this isn't meant to be arrogant, this is just like the production manager is always very busy. So when the production manager is responsible for the digitization, sometimes it takes a little bit longer because as you from OT all know, a production manager has a lot of things to do. So, excuse me, what's happening here? Okay, yeah. Now it's the right presentation. Excuse me, guys. This is a little bit of a hiccup, but I'm going to start again, right? So just stay with me. Thank you. Thank you so much. So I've been there, all right? So in the last 10 years, all the use cases took way too long. And if it takes too long, you risk losing competitiveness. But it's never just about one single use case. So it's not even one use case that takes too long. It's always a whole bouquet of use cases. So it could be predictive maintenance, traceability, it could be digital QA, it could be energy management, it could be an OEE dashboard, very popular, or HEV orchestration. So that's like the most popular use cases we've seen at customers, or that our customers implemented. And what I didn't tell you before, because the slide was missing, what we are doing is we are a software vendor, right? So we we have a factory data hub for our customers so that they can implement all those use cases on a very scalable level, because they have one single entry point for the data. So the factory data hub is collecting all the data from the shop floor. We heard it before that the connectivity to the shop floor is always like very time consuming and also very important. So we solve the problem of connectivity and of the standardization of data and of aggregating data and of distributing data to various target systems. I'm going to show you that later. So those use cases always consist of various dimensions. You have input data on the left hand, you have output data on the right hand, and an optional user interface. Maybe I'm going to introduce you to that, and like a specific use case with certain business logic and algorithms. And those use cases are always having like a business outcome and an owner. So as an example, in energy management, the owner usually or sometimes is in the operations department. The outcome is to save costs, like energy costs. It's pretty tautologic, but I know, but I just want to give you an example. The input data could be power consumption or machine runtime, and the output data could be the forecast of energy consumption, monitored on an energy dashboard. So this is just for introducing you into the topic of input data, output data, right? In traceability, this could be like the outcome of compliance, most popular at automotive suppliers. Like they need to trace their processes, they need to trace their orders, their products, and deliver this also to the customer to comply with their Q&A. The input data there is process data and order data. So process data means like real data from the machines, from the process, from sensors, and order data, for example, from MES or ERP systems, or like from the item which is produced itself. So you get that this might be complicated, but I'm going to get into that later. The output data for that in traceability is the like events of quality anomaly, and you save this in a database. So this has been like a show of 2 use cases, but it's always more. I told you that, like it's sometimes 7, 8, 9, 10 use cases, or even more. There's a lot of digital use cases around, but serving all those use cases can be quite complex in very complex cyber physical systems. So what we can see here, and I'm not showing even the layer of MES or ERP systems or databases in here. It's just the use cases. It's just for you to see how complex it can be to connect all those different use cases if you connect them singularly to the various machines that they need the data from. So it could be way more lines here. So if you look, for example, at digital QA, it's only one line to an edge device. It should be like connected to everything. But here you can also see that even in those complex cyber physical systems, the data knowledge and the data demand are sometimes decoupled. So the data demand mostly is at the business owner or the use case owner. The data knowledge is in the OT regularly. Like in the OT, you have people from maintenance, for example. They definitely know when your machine sounds weird, when your machine is needing maintenance. And what I want to tell you is that you can, or that you should connect the business owner, which can be in business or in IT even, with the OT. So OT-IT convergence, a very big buzzword here. And how do you do this? How can you bring them together? How can you bring the knowledge from the OT to the business use case owner or to the IT? And this is done by giving you or the IT, the business case owner, the data knowledge, input data giver, transparency and governance over your data. But how can I give transparency and governance over the data? Yeah, you can achieve this via a factory data hub. Of course, I told you I work in sales. We have a factory data hub. Big surprise, but what the factory data hub is doing, it's aggregating or collecting all the data from the shop floor, standardizing it, and distributing it to your use cases or to the systems where they are needed. This sounds quite easy, but the technology behind this is very interesting, because like when the factory data hub is involved, it gives your IT the governance over your data, so it can govern who gets the data, where does he get it from or she, and who is even able to use the data. So it's also a security aspect, like a governance aspect, and yourself or the use case owner can have the transparency over the data. He or she can see what's actually going on there, like even live in real time. So, for example, if we take a look into traceability, we have the connection between like the machines which give the process data and the systems like an MES or an ERP where you get the order data from, and then you can connect them. So we work as a factory data hub bidirectionally. Then you can connect them, aggregate this data, and put this into a database. Like a pretty simple example, but what I want to show you here is that the IT in that case acts as a shared service. So the IT is governing the factory data hub and gives the data knowledge to the business use case owner who constantly needs data. So the process and order data in the example of traceability is given to the use case. Okay, also not the biggest deal, but the IT within a factory data hub like Cybers, because we work infrastructure as code. If you're interested in that, we have an exhibition booth behind there. And the IT can use the principles of industrial IoT. And that's the point that I'm just introducing right now. So the industrial DevOps cycle, which is shown here, you might need opera glasses behind there, but I'm going to show it bigger. The industrial DevOps cycle here, it allows the IT to do this in a DevOps kind of manner. But what is industrial DevOps? You see here the connections between the production, the development, the business, and operations. So I'm going to read this because it's quite a complex definition. Industrial DevOps is the approach to apply methods from regular software DevOps to the development and production of industrially manufactured products. It's a little bit cryptic, so I'm going to show it how it is done. So if you think about use cases, for example, you want to connect machines, you have a certain configuration, you have machine configurations like parameter configurations, and you want to get this into doing. Industrial DevOps allows you to test this and put this into a staging cluster where you can test and try without harming your production. And if the test was successful, you can actually deploy this into the productive cluster so that you don't risk of messing up your deployment. So if it's in the production cluster, then you have the use case productively running. What I want to show you here is just that you can implement ideas and use cases very quickly and without risk with industrial DevOps. And this was also very abstract, so I'm getting into a little bit more detail. I don't want to bother you too much with the DevOps cycle, but the DevOps cycle basically consists of planning and developing, testing, releasing, deploying, operating, and monitoring, and this in a loop. So it's always a continuous progress. So what you can see here is that the use case owner or the connector user is writing a commissioning file. So we are working infrastructure as code because of the scalability and the availability to do this industrial DevOps stuff. So he's writing the service commissioning file where is all the configuration in it of connecting to machines, the rule engine, so like the data aggregation, the data cleansing, the data formation, the data normalization, etc. You get the gist. And then he or she can push it into the Git, like for example, like Git, a version control, where it's controlled and where it is tested. And then if it's tested or within the staging cluster, it's triggered into a CI/CD pipeline, which is running very quickly and automated. And that's where I got the question beforehand, where does this 20 times faster rollouts come from? So I'm going to explain it right now, or like in 10 seconds. the CI/CD pipeline is the automation behind all of this. And this gives you the velocity, the rapid rollout. So the CI/CD pipeline automatically executes all those commissioning files, which can be, and I'll show you that, like 1,000, 2,000, 5,000 machines, which are automatically deployed in a couple of, if it's one setup, a couple of hours. And then it's tested and put to the staging instance, released to the production instance. And so you can run it like on plant 1, on plant 2, on plant 3, on plant 4, on plant 5, on plant 60, on plant N. So that's what this all about. Quick implementations of factory-wide use case rollouts across plants. Like today we heard about a use case like on 65 very different plants, quickly rolled out. But this is also a very good tool to do this, like to really automatically roll out use cases on a lot of factories. So this is where our customer base is from, and this is why our customers buy us. And who's our customer? I'm going to give you a glimpse. And then if it's an operation, you monitor it. And if it's not working, you can redo it again. All right, so I'm quickly heading into the example of our automotive customer. Some of you might have a car. It's not Sachsenring, it's not a Trabant. It's quite a luxurious one. So how did they start? How it began? At our customer, the strategy has been set up beforehand. So they had a digitization strategy. They had a whole roadmap, and then they used us, like our factory data hub from Cybers, for creating a POC at first in one plant, in plant 1, and creating there a center of excellence of 4 people, like actual 3 users and 1 guy who is surveilling, like managing the project. And then they rolled it out on the whole plant. So in the first year, or in year 1, they created the connectivity to over 1,800 assets, and they realized over 3 use cases. So in that case, it's 3, but in the second year, they moved those 3 use cases to the second plant and rolled it out there with the same center of excellence, and in a very short time, and even more than tripled the amount of use cases. So we are speaking here about HEV orchestration. We are speaking here about traceability. We're speaking about torque. I'm missing the English word, but like torque drivers, they have torque, and you have to surveil that. And there they connected 5,000 assets, and in the end, they had 2 plants. The third plant is already in project. So to be quick, because I lost a little bit of time, in a nutshell, governance and transparency is the key and is necessary to combine the data demand from your shop floor, from your top floor, like from the business, the use case owner, with the data supply, the OT. So digitization can be done very quickly and way better if you have the safe and fast opportunity to test it, to test your ideas and use cases. So the whole industrial DevOps idea. And if you create an internal shared service for data and the data hub, you can accelerate your digital initiatives. And if you're interested in seeing how this works, like in a demo, or how this can look like the automated deployment of like, for example, PLCs, we have a little demo on our exhibition booth. So please feel free to check it out. And if you're interested in like a cloud setup or the cloud first contradiction, I'll just leave you with that headline. You can scan this. My colleague Benjamin is going to tell you a lot about this. It's a very interesting topic. It's on next week, like 28th of March at 10 a.m. It's online and for free. And I thank you so much for your attendance, and also like for listening to me, even if the presentation didn't work that well. So if you have questions, feel free.
Thank you very much, first of all, and I think first big applause.
Thank you.
You managed very well. So is there any question for Lucas? Well, then I have one.
Yeah.
The question, I mean, I understand the fast deployment of the applications and of the use case, obviously, because once the establishment of the connectivity to the different assets has been done, but still, if you go in a brownfield environment, the connectivity towards your data hub still needs to be done.
Exactly, and I think you're going into the direction of the heterogeneous PLCs, protocols, etc.
Right.
Yeah. Okay. Yeah. Okay. I forgot to mention that we solved that, right? We have a protocol mapper within our software solution. Of course, like the connectivity is sort of a commodity. So you have the ability to connect to all your PLCs, be it as an S7, be it a Heidenhain, be it Beckhoff, be it even like sensors via I/O link. I don't know, like a lot of it. So then it is.
But the data mapping still needs to be done then.
The data mapping is also within the factory data hub. The mapping is done in one of the parts of Connectware, which is called Rule Engine, and it's all configuration. It's never customizing. It's all configured in the Rule Engine where the data has to go, where how you normalize the data. Like even if you think about cloud use cases, for example, what kind of data is sent into the cloud? Not that you have every data point from every PLC in your factory in the cloud. That's very expensive. So that there you can configure what kind of data can be sent there.
Yeah. Okay.
That's the whole purpose about this. Yeah.
Well, thank you very much, Lucas.
Thank you very much.